In this video, we're going to look at how to factor a binomial that is both the difference of squares and difference of cubes. What approach should we take? So let's look at your basic formulas. We have difference of squares for a binomial. X squared minus y squared is equal to the difference and the sum of the square roots. So the square root of x squared is x, square root of y squared is y, so we have x minus y, x plus y. The difference and sum of the square roots. Very basic formula for factoring binomials. Now, here's your formula for the difference of cubes. If you have a difference of cubes, the first factor will always be the difference of the cube roots. Cube root of x cubed is x. Cube root of y cubed is y. And then the second factor will be the square of the first term here of the binomial. And then the opposite side of there, plus the product of the two terms, x and y, plus the square of the second term, y. So we got x squared plus xy plus y squared. And if you have a sum of cubes, very similar formula as you can see there. It's a plus x plus y. And the only difference is over here in the second factor, it's opposite. Plus over here, minus over here. But it's similar to the difference of cubes. So now, what happens if you have a binomial that's a difference of cubes and difference of squares? So let's look at this example here. Suppose you wanted to factor completely x to the third minus x to the sixth minus y to the sixth, or something in the same format. So I rewrote this in this form so you can see that this is a difference of cubes. X squared cubed, the rule is to multiply the exponents, you get a 6. Y squared cubed, the same thing. So the point here is that x to the 6 minus y to the 6 is a difference of cubes. In the same way, I can also write it as x cubed quantity squared minus y cubed quantity squared. Again, multiplying the exponents, I get 2 times 3 is 6. Over here, 2 times 3 is 6. So this is just to show you that x to the 6 minus y to the 6 is a difference of cubes and also a difference of squares. So if we're going to factor this, let's look at this. X to the 6 minus y to the 6. And look at that as a difference of cubes. And let's see what we have here. But for the difference of cubes, the first factor is the difference of the cube roots. So the cube root of x to the 6 is x squared. The cube root of y to the 6 is y squared. That's your first factor. Okay, from the middle formula up here. X cubed minus y cubed. And then the second factor is the square of the first term. So x squared squared, multiply the exponents, so 2 times 2, that gives me a 4 here. And then it's the opposite sign, so this becomes a plus. And then it's the product of the two terms, so that's going to be x squared y squared plus the square of the second term. So y squared squared, that just multiplies the exponents 2 and 2, that's going to be a 4 here. And then you look at this and you wonder, well, can this be factored? It appears that that's as far as we can go. But notice, if this middle term x squared y squared had a number, a coefficient of 2, then that trinomial would be a perfect square. So in other words, let me go over here and do this. Well, first of all, let's factor the first one here, x squared minus y squared. X squared minus y squared is a difference of squares. So by the formula up there, first one that I wrote down, this should be x minus y and x plus y. Okay, now if I look at this one here, like I said, it appears that you can't factor it, but let me rewrite this as x to the fourth plus, and it would be nice if this were a 2 here, so I'm going to put a 2 there. 2x squared y squared. And then this will be plus y to the fourth. And obviously I just can't change the number there, because then I've changed the problem. But that would be legal if I subtract minus 1, or I'll just make it minus x squared y squared. So the expression then becomes the same thing, because notice 2x squared y squared minus, this is understood to be a 1 here, minus 1x squared y squared gives me the same thing back. So now let me rewrite this now. This obviously is going to stay the same, x minus y x plus y. And then I'm going to rewrite this here. X to the fourth plus 2x squared y squared plus y to the fourth. That can be factored into this. It becomes a square trinomial. So I can rewrite it this way. X squared plus y squared, quantity squared. This is the same thing as x to the fourth plus 2x squared y squared plus y to the fourth. And then I have minus x squared y to the squared, y squared. Okay, so now this first expression here is a square. So this is one term squared minus another term, and of course obviously I can rewrite this as xy quantity squared. Okay, xy in parentheses and a square. So basically I have a difference of two squares right here. So I'm going to rewrite this way. Okay, the x minus y and the x plus y are going to stay the same. Haven't done anything to those. And so now this part right here then, you can look at that as a difference of squares. This is the same thing as having, say, a squared minus a b squared, where the a would be this x squared plus y squared, and the b would be the xy squared. Okay, difference of squares. So I can use that first formula that I had up there. So the square root of this is x squared plus y squared so x squared plus y squared, and then minus the square root of this x squared y squared, of course it's just xy. Okay, so that becomes one factor. And then the other factor is just going to be the same two terms, or same terms, except it'll be a sum of the terms. So this will be x squared plus y squared. Again, you have a difference of squares. One factor will be the difference of the square roots. The other factor will be the sum of the square roots. So again, this is going to give me then a plus x y. And this is your complete factorization for this x to the 6 minus y to the 6 using the first method, which I looked at as a difference of cubes. So I used the formula for difference of cubes. And this is what we got. X minus y times x plus y, and then again parentheses x squared plus y squared minus xy, again parentheses over here on the other side, x squared plus y squared plus xy. So now, what happens if I look at this as the difference of squares? So looking at this right here, what is it? It's difference of squares. So let me write this over here. So I have, so I'm saying x to the 6 minus y to the 6. Those are the difference of squares. So let me do this and say the square root of x to the 6, as you can see by the setup here, is x to the 3rd. Minus, and then of course the square root of y to the 6 is also y to the 3rd. Okay, so using that formula, one factor becomes x to the 3rd minus y to the 3rd, and then the sum of those same roots. So x to the 3rd plus y to the 3rd. So if we look at this difference as a difference of squares, then the first factors I get are these right here, x cubed minus y cubed, x to the 3rd plus y to the 3rd. But now of course I have difference of cubes and sum of cubes, so I can use this formula here and this formula over here. So let's do that. X to the 3rd minus y to the 3rd, so let me put it here, equals, but I'll go ahead and write it over here. So x to the 3rd minus y to the 3rd factors into x minus y, difference of the cube roots, and then the other factor, as we see from that second formula, is the square of the first term, x squared, sign changes to a plus here, the product of the roots of the terms is xy, plus the second term of the binomial squared, gives me that. And then for the second factor, the sum of the cubes, x cubed plus y cubed, pretty much the same. First factor is the sum of the cube roots, so this will be x plus y. And then the second factor will be the square of the first term plus, or I should say minus the product of the two terms, that's x and y, plus the square of the second term of that binomial. Square here. And we get the same answer as we got the other way. Okay. So when we did it with treating it as a difference of cubes, after we simplified and basically we completed the square. Okay, right here. In this step right here, we're actually completing the square of the binomial so we can continue the factorization. So this is the answer we get using the starting off with difference of squares. And this is what we get over here if we treat it as a difference of cubes. Notice we got the same thing. These are in different order, but it's the same thing. Multiplication is commutative, so got an xy and an x plus y. There's your xy and x plus y. We have an x squared plus xy plus y squared. Here it is over here. Okay, x squared plus y squared. The xy is over here, but of course you can put it over here. That's not going to change it. We have an x squared minus xy plus y squared, and we have it here, x squared plus y squared minus xy. Same thing as putting it over here. So this is the answer we get here, and this is the answer we got over here. That's the same answer. So the point we're trying to make here is this. If you have a binomial that is both the difference of cubes and the difference of squares, you can do it either way, but if you go difference of cubes, it's going to be a little bit more involved. See here, we had to complete the square, whereas over here, we went directly to difference of squares, and we got the difference of the square roots, the sum of the square roots, and those turned out to be difference of cubes and sum of cubes, and then we just applied those formulas. So again, the point we're making again is if you have a binomial that's the difference of cubes and difference of squares, it'll be a little bit more easier if you take the first approach, and go difference of squares to finish the problem. Thanks for watching. We'll see you next time.